So I'm Sean. Most of you have met me or seen me at church before COVID or on Zoom. I was often the guy bouncing a baby in the lobby during service. And that's Edra, our youngest, and we have 3 kids. So a lot of you have met my wife and maybe my children, Fletcher, Archer, and Edra. And we've been attending since 2019, September of 2019. Well, we've talked many times about how we found UUSS, but we really enjoy the community there. And it's great to have people with shared ethical values, but with that, spirit of exploration rather than funneling you into a rigid vision. So I love that. And this subject matter ties both into my professional career as an engineer. Engineering wasn't my first focus. I didn't go straight through in school, but I graduated in 2013 and with a bachelor's in mechanical engineering from UC Davis. And during school and immediately after, I was working on plug-in hybrid electric vehicles. I was also working on transmissions that were oriented towards those those types of vehicles. But I worked on a hybrid race car in school, and I worked for over 3.5 years or something, partially before and during the degree, and then later as a salaried engineer for a company out in Dixon, California. That was making plug-in hybrid trucks mostly. We also did buses for China and taxi cabs and stuff too, that were complex hybrid systems. And that's a subject for an offline conversation. But so that's where I cut my teeth on electric vehicles. And this was when Tesla was only just making the Roadster. So it doesn't sound that long ago, right? 2013 is like really not that long ago, but in the span of electric vehicles as they are in the market as we know today, that was like an eternity ago. And yet the life of those vehicles has not come even close to an end. But we're adding more and more and more of these cars on the road. And something has happened to them when they go to the end of life, and we'll talk about it as we go through the slides, which I'll pull up here. But current gas vehicles have a very high percentage of recycling that occurs. They I have the exact number, but it's over 95% or over 90% of the vehicle is fully recycled in your gasoline vehicle. So in terms of the impact of a vehicle start to finish, the gas vehicle is mostly how you use it, right? So what it consumes while it's being used. And as more vehicles are added than previously existed. But if you have about the same amount of vehicles on the road at any time, it's, most of the new vehicles are made based off of old vehicles. So there's a really nice loop there that occurs. And that loop hasn't been established yet with electric vehicles. Can someone confirm to me that you guys can see the slides? Okay, great.
Not at the moment. We did, let's see.
Oh, you did, but now you can't?
Yeah.
Okay.
We're still seeing it.
I see a slide.
I see.
We can see it. We've cut David out, but everybody else can see
Cut
it.
me out. Okay, hold on. Oh, wait a minute. Oh, there it is. Oh, okay. I did have it.
All right, so you can see me changing the slide then.
Yeah, somehow I need to get it back in my full swing. There it is. I got it.
Okay. All right. So yeah, I started to talk about this a little bit. I started it that plug-in hybrid electric vehicle and plug-in electric vehicle startup in Dixon, California. It's near Davis. And from there, I transitioned into designing electric motors because one of the big pain points we had as engineers there was there were not electric motors well suited for moving the vehicle. So we were using motors from like light rail trains, for example, where they don't care about how big and heavy the motor is because it's just rolling on rails. And that's not suitable for vehicles. So I started learning about electric motors and I shifted to that. And that also related to electric vehicles. I ended up designing for 2 different companies, big electric motors for electric vehicles. And one of it, which is an automotive supplier, but I'm not allowed to disclose at this time. And then I also, during that time in Dixon, we had to play around with some of the early batteries that were available, like commercially available. So it's possible you've heard, there's a couple, like A123 was a big company at the time. They still exist. There was a couple other companies that don't exist anymore that we were using these huge battery packs. They're 600 to 1,200 pound bricks essentially of lithium batteries. They have monitoring equipment in there because many types of lithium can start horrible fires that can't be put out with water. And so there's like, you hear in the news about, oh, that car set on fire, or there's the Bolt fires recently and stuff. I mean, you don't hear about the far larger numbers and percentages of gasoline vehicles that set on fire. They also do that as gasoline likes to burn pretty easily. But the difference there is you can put those fires out. So from the fire department's perspective, they'd much rather like a gas tanker crash and burn than one electric vehicle because it's so difficult to stop a lithium battery fire. I can answer questions about that. There's a lot of technologies that are coming on market or will be coming on market potentially that kind of completely eliminate those issues, but that's a concern a lot of people have. So I have a lot of experience cutting open those battery packs and monkeying with them because they were not really well built, even though some of those were going into buses and stuff that are still operating today. And then I did purchase an EV after I got my engineering degree. I had a Chevrolet Spark electric, which I just loved to death. We ended up letting that go because I just wasn't commuting. I haven't been commuting for years until just recently. We let that go last year. Now, of course, I'm commuting again, and I wish I had it, but it was sitting in the driveway mostly for a few years because we barely went anywhere. And it's a 4-seater, and we have 3 kids, so that made that tough. And I will definitely be purchasing an electric vehicle in the future. This really ties into 7th principle kind of issues. And for me, I call myself a 7th principalist, but like I really, really believe in the interconnectedness of stuff. I love things like permaculture, which you may or not be familiar, but it's sort of a nature mimicking system, often used for agriculture in small and now in increasing large scales. But that portion is not critical to this, but I wanted to borrow something from permaculture, which is the zone map. This gets used in other things such as lean manufacturing and all kinds of stuff that has absolutely nothing to do with growing or nature, but they have a really simple version, which is really good in permaculture. And you think about the smaller the zone number is, the closer to you and the more frequently you interact with it is. And so when you look at what do I change in the sense of permaculture, what do I change in my property or in my life or my social life in order to maximize all the good things, happiness, food, and all this stuff that you want from that.
I thought it was.
You focus on the zones close to you.
I had to download a specific Zoom for it to work.
But so I'm going to talk about a little bit.
I don't really understand what he's talking about, your zone and how that relates to electric.
I wonder if we could mute.
Transportation.
Is it possible for you to mute your audio, Doug? But so if we think about it in terms of your electric vehicle, there you have your experience as an EV owner. And the reason I want to talk about the zones is because a lot of people don't think that what happens out there, mining materials or recycling the car, really has anything to do with their direct daily life. And I want to talk about it because from the seventh principle perspective and from these zone perspectives, that it really does. So you can think about, okay, well, you're driving the vehicle. That's
Yeah,
something you
electricity,
deal with every
green, I
day.
need solar if my car isn't cool. Yeah, okay, thank you. Talk to you soon, buddy. Talk to you
And
afterwards.
then we have the charging equipment that you're dealing with almost every day. And then as you're going out, well, you're thinking about how much does the electricity cost? You're thinking about, oh, wait, there's specific parking spots. I get extra parking, you know, closer to buildings that has a charger. So these are good things, bad things. Is there charging where I go to? Do I have to worry about somebody vandalizing my car? So those are ownership concerns. And you go out, so on and so forth. And you start thinking maybe eventually way out there, not closely related to you. Well, man, where did all this lithium battery stuff come from? You know, how did we get it? How did we make it? Is that green? Where does the electricity come from? Is that green? What happens to my car if it wrecks or burns or is just not useful anymore? And is that green? And then how does that relate to your zone zero, your home life, right? That's like really far concerned. You know, it's getting mined somewhere in Arizona or whatever, or in Peru for copper. Like that has nothing to do with me. When it gets recycled, that's somebody else's problem, right? They're making new cars all the time. That's not my problem. But if you think about in terms of electric vehicles, the demand for these materials like lithium and copper is going to be so huge as everybody gets their electric cars, because that's kind of the goal. The government and a lot of agencies and individuals, is for everybody to convert almost entirely to electric. There's so much material that goes into these electric cars and into the infrastructure to charge them that we didn't have to deal with before. So, and that material is in your daily life. So you got lithium batteries in your cell phone, in other devices, in watches, even your remotes sometimes have coin cell batteries for like your car that are lithium. And that lithium is basically being fought over right now by all the electric vehicle supply companies. So that's something that could really impact. What happens if you can't get a battery for your phone, or your phone battery life has to go way down because it can't be a lithium battery, or the cost goes way up instead. And suddenly your battery that was $40 is now half the price of the phone. And then copper is another big one. There is a lot of copper that goes into an electric vehicle, has huge amount of wiring in it and in the motors. But there's also all of the wiring to get electricity to that vehicle that sits around in the grid, and it's not used very often. And it's sometimes 2-3 times as much as like a local municipality had to deal with in terms of copper. And when you add all that up, it can start to really impact demand for copper and pipes in your home and other wiring, which is commonly copper in your house. The big cables you see going overhead, those are usually steel. When they're going way out over the countryside, it's cheaper and they can just make it big. But in your home, you don't want to have giant steel cables that don't conduct as well. So we use copper. And so that's something that comes right back to directly affecting your life, in addition to the ecological impacts. And then I briefly mentioned this before we started, but today I want to just kind of focus on that. Where do the materials come from? And then what happens when the vehicle's done with? And I know the questions a lot of people have is, what is it like to own a vehicle, and is it green while I'm driving it? And those are important questions. And I want to kind of, unless we have time for them today, kind of set them aside for the next class, because that's a big topic that can easily derail these other questions. So then we're going to talk, so we'll talk about the raw materials on the left there and the end of life today. And if we talk about where does it come from, sorry, this is a little bit blurry. The raw materials, in the battery, we're mostly using cobalt, lithium, and nickel, and graphite, and then copper in the motors and wires and things like that. And of course, the vehicle has a lot of steel in it, which is no different from, and all the other elements that are the same with the regular gas vehicle. I am not able to see everybody with the presentation up, so I didn't know if anyone had a question at this point. Okay. So in terms of the ecological and the ethical impact of the source materials, this is a big issue right now in electric vehicles. Cobalt in particular, that's not the hot button topic. People think of lithium as the hot button topic, and it is an issue. But the main issue in terms of ethics and supply is cobalt right now. It comes almost exclusively out of the Republic of Congo. And so that's a conflict area. So we would normally not source anything from there in a large industrial quantity due to political conflicts and ethical conflicts there, but it's like literally the only active source of cobalt in the world. So anything you get that has cobalt in it is either recycled from something or it came from there. And even if it's recycled, it came from there pretty much exclusively originally. And that's almost entirely refined through China. So that's another big political, economical, and potentially ethical concern there. You know, if when we were in a trade war with China, cobalt became like an almost non-existent material in the US market, and EV companies had a really hard time making batteries. And that's not something that gets talked about a lot. So there's a lot of research into getting rid of cobalt mostly or completely as a major material in electric vehicles, but that's still an issue. And it's not that it doesn't exist at all in other places in the world, but that it exists in such small amounts that we're not aware of any major deposits outside of the Democratic Republic of Congo. The lithium, go ahead.
Oh, Sean, I'm sorry. While you're still on cobalt, we have a question from Ray that says in chat, why do substitutes, I'm sorry, what do substitutes look like in coming years for cobalt, copper, etc.?
Well, in the copper question, it's pretty easy. Aluminum is a good substitute for copper conductors. It's bigger, like it's about twice the size. Like if you were to look at a cable that conducts the same amount of electrical current, but it's similarly easy to work with. It's actually more durable in a lot of ways. It's cheaper. It's cheaper to produce. It's cheaper to deal with throughout the manufacturing line. It's cheaper to refine. You know, there's tons and tons of aluminum sources from all over the place. Aluminum is not a problem material compared to other materials. It does make the wires bigger. It doesn't make them heavier though, but a bigger wire for engineers, the big problem is a bigger wire has to take a big bend versus a small bend. And aluminum has to take an even bigger bend for the same size than copper does. So they really fit huge wires in for like the electric motors. And so that's the main reason they haven't switched to aluminum. And then if you think about, I did electric motor design for the last 6 years. That electric motor we're trying to make it smaller and smaller and smaller. And if I put in aluminum, I have to actually make it quite a bit bigger to fit the wire inside. So it's like counter to my goal as an engineer from a performance perspective. But that would be a good alternative for copper. For cobalt, there's a ton of possible answers, and it looks like so it's mostly used in the batteries. People talk about them. There are high performance magnets, samarium cobalt, that use cobalt. They don't use very much cobalt, and they're also not usually the choice for motor designers. They're really, for reasons, they're really brittle. They're not as strong as a magnet, and they're mostly useful when it's going to be super high temperatures and you don't want the magnet to fail, but you can design away that problem. So samarium cobalt magnets are not really the issue. It's usually the batteries themselves involve a lot of cobalt in the battery anodes or cathodes. And so they're getting away with that with all kinds of novel designs, but that's like, there's like 100 solutions to that problem right now. And none of them has shaken out as a dominant or commercial solution yet. maybe 5 years probably before we start to see the first of them come in the market. And it probably won't come with much fanfare either. It'll just be, you know, it's a supply chain headache more than a public ethical headache right now, even though it's a legitimate ethical headache. It's just not being made one publicly. Does that answer the question, Ray? I can't see the chat for some reason. But
Yeah, thanks, Sean. That was great. I appreciate it.
awesome.
I've got the chat up here. We have another chat question from Steve Hoverman. Will Sean discuss the iron flow battery option?
I will have to research that.
Or, okay, battery flow. Or
There
iron flow battery option.
are flow type batteries which have a liquid instead of having solid materials in what they call an electrolyte, which can actually be a liquid or a solid, but that allows the chemical reaction to happen without the two halves, the anode and the cathode, which are like the negative and positive side of the battery that have the bulk of the active material. Those can't touch, so they get separated usually by a fiberglass mat or something like that that's non-conductive. And then there's some medium that can allow ions to go back and forth between them. It's often a liquid. Now there's solid state batteries. You'll hear about that if you're looking around on the internet or on the news, and those just have a non-liquid electrolyte. A flow battery has the anode and cathode are actually like liquid tanks. And then they're passed across either side of a barrier that has that lets the ions go through, just like that glass mat with the electrolyte and the solid anode cathode battery, but it doesn't let the liquid material go through. And so it works on the same principle, but you have like big liquid tanks and you can just kind of keep pumping it around instead of having these solid things. And there are challenges when you're dealing with the solid elements because they expand and contract as the battery is charged and discharged. And so if you manage, you've crammed everything into a little tight box that can't move and it suddenly gets bigger, that's a problem. But if you got a liquid, you're just pumping it around. So it doesn't matter, it gets bigger, that's happening in a tank over here. So I don't know much about those being used or researched in electric vehicles because they're not usually as high performance, but that may be the case. There's a big market for those in stationary stuff, like at your house or for grid power management. But I'll look at that. I haven't heard of an iron flow battery, so I'll definitely check that out. There's so many solutions. I get magazines and magazines, and like I couldn't possibly read through them all. And they just talk about, 3 different new solutions in every magazine at a research level. Hopefully that answers the question to some degree. Am I missing any more questions, David?
No, I don't see any other questions right at the moment, but if anybody has, they can go ahead and put them in chat, or if you just want to ask him.
Yeah, I have you guys up on gallery now, so I can.
You can have them like that, or you can have them like that. See?
Has it on gallery, yeah. Yeah.
I don't know. I don't think I'm even on a chat. I didn't use your pad because I had to download their version of Zoom.
Hey, Doug, we can hear you though.
Oh, I'm sorry. Yeah.
So if we don't have any more questions, lithium was the next on the list. Lithium is the big word that people hear when they hear electric vehicle batteries. That also, just to preemptively answer the question, that also has the potential to be removed completely or almost completely from batteries. And even in current batteries, it's a very small portion. Still, despite lithium being one of the most common or the most common metal that exists on Earth, it's not in high concentrations in very many places that make it like cost effective. It's just everywhere in like a really small concentration. So right now it's mostly mined in Chile and Australia. In Chile, there's some ethical concerns. Those mines have been around since I forget what it is, the 70s or the 80s, but they've caused a lot of destruction, cultural and ecological destruction with those mines. But the mines in Australia are well managed as far as strip mining operations go. So they didn't go in and displace a huge amount of people or destroy entire mountains, for example, to do that. So that's the preferred source most of the time for lithium. A lot of people don't realize that one clever thing that Tesla did, or Elon Musk running Tesla did, is they went in and they secured exclusive rights to most of the world's supply of mineable lithium. And so it was a very clever thing that he went in and he got these rights when lithium mining was just this thing that basically nobody did because it was so low value. So he went in and secured rights to potential mining sites that nobody cared about when it was really cheap, to guarantee that Tesla could make batteries as they ramped up. So a lot of their competitors right now, if you're thinking about in terms of like what will be available going forward in the future, a lot of their competitors are having to put a lot of money into researching low or no lithium batteries just because they simply cannot get large supplies of lithium, but Tesla can. I forget what the exact amount is. It's hard to find a real number because they keep a lot of these dealings pretty hush hush, but it's well over 70% of the global potential mineable supply of lithium that Tesla secured. So the one thing to think about with mining is there's what we know we could go and stick a shovel in and start mining today. And then there's way, way, way more about it that we just haven't found. So having a large part of today's supply when people didn't really care to look for it doesn't mean it's a large part of the real supply. So you can think about it that way too, but it's a big part of what could be mined today. And then nickel is generally produced almost exclusively in Indonesia. And there aren't any major ethical or ecological issues that I could find about that. One thing that's hard about researching this material, I love to research things to do with end of life. Plastics is an absolute traumatizing nightmare if you research what happens to plastics end of life. So I don't recommend jumping down that rabbit hole unless you've got a strong stomach for it. But it's really hard to find information. Generally, metal suppliers like this are pretty upfront and saying this is how we do it because they're doing it the same way everybody else is doing it. So they don't feel any compunction whatsoever. So they tend to just be kind of like, yeah, we strip mine and we do it this way. So I wouldn't say that nickel is any worse. In Indonesia, I couldn't find anything that suggests that it's any worse than any other metal done in the US, for example. So you could say it's at least to US standard of treatment, which is not necessarily the standard you'd want it to be, but it's not as bad as like the cobalt operations, which are pretty bad. So then that pretty much covers everything I could find regarding the raw materials going into batteries. Graphite is another huge one that goes into batteries, but that's producible basically as a advanced form of producing charcoal. So it can be produced sustainably. It is mined some, but it's also sustainably producible with sustainable food, or not food, sorry, forests, and other sources like that. Anything that can be combusted and turned into carbon, which is just an incredibly common industrial material. It's in lubrications that are used like for your doorknob and stuff like that. I mean, people may have had the graphite powder. People used to carry that around. It's in pencils. It's really common in electronics. So graphite is a huge volume in electric vehicles compared to like a gas vehicle, but that's like not a concern material whatsoever. And then the other end of the spectrum, I'm assuming there's no questions right now, David. You're muted.
I'm on mute. It doesn't look like there's any new questions.
Awesome. So the other end of the spectrum is what happens after I'm done driving my vehicle. Either it got in an accident or the battery wore out because I drove it so much. The electric motor wore out. When these vehicles are 15, 20 plus years old, even beyond accidents, they're just going to come to an end of life where people don't want them. So they get junked. And then how does that compare to a regular gas vehicle? And I had mentioned this before, gas vehicles are, I had said 90%, it's 85%, up to 85% of the vehicles recycled. And most of that material is used again to make another gas vehicle. That's, steel is a huge part, and aluminum is becoming a huge part of all vehicles. And those are super recyclable. You can recycle it right back into what you started with. Unlike plastics, very few plastics can be recycled and then reused for the exact same purpose. So there's no infinite recycling life for almost any plastic, but there is with metal. So in a lot of ways, metal's heavy. It requires big, expensive equipment, a lot of electricity to produce, and so there's potentially some complaints there. But in terms of recycling, you can just keep recycling that metal over and over and over again, which is absolutely fantastic from a long-term ecological standpoint. So you can use, and it just needs electricity. So you could use solar or wind or hydro if you felt like that was ecologically sound, or nuclear, whatever green or hypothetically green power source you wanted can be used, and it's increasingly being used for metal processing and recycling. So that's a good argument for, hey, gas vehicles are already pretty green in terms of not the driving part, not the gasoline use part, but in terms of the manufacturing start and end of life, because they're largely being made from other gas vehicles that got taken off the road. It's the same thing for the lead acid battery. That battery everybody knows in their car, that's very largely recycled. The lead is a metal, it's very recyclable. It's actually very, very cheaply recyclable. And the acid is also recyclable. So that makes them good. It's mostly the plastics in lead acid batteries that don't get recycled. And someone will probably ask, what happens to the plastics? So the automotive industry doesn't just chuck them in the garbage. They will recycle what they can, usually into something that doesn't require as high performance. So your dash, for example, might be mostly recycled plastics from other plastics that were on older cars, or waste from making other parts that were higher performance. But when they just can't recycle it in an economical way, what they do is they do shred it. So they shred it into like fibers. And then that's what's like in your seat. Sometimes that's what's in your dash that's making the engine sound quieter. So if you take apart car, you'll find this sort of crazy gray and rainbow colored fiber fill kind of stuff. And that's like the plastics and the leathers and all the elements of the car that couldn't be easily and economically reused. But it's a pretty closed loop cycle overall. So, and that happened around the 60s. Some of you may remember, I don't, I wasn't there, but I guess there used to be lots of junkyards that would exist along freeways. I found tons and tons of pictures of this. And when a car would get towed off the freeway because it was totaled, it would just get stacked in a junkyard if the person wasn't gonna repair it or take it. And they'd pay like a flat fee and it would just get stored there for life. And then local and state governments were permitting these sites as like permanent dump sites for the vehicles, because the metal, steel, and everything was really, really cheap. So they could build cars from new materials really cheaply. There was no shortage. And recycling was something they just didn't do. Nobody had thought to do it. So there started to be these mountains of cars, and then purely for aesthetic reasons is what I can find. There was this Highway Beautification Act in 1965 that required these junkyards to go away because they were visible from the freeway and it just made it look bad. So they were told they had to go away, and the solution that was proposed was not to just pick up the cars and dump them further away, but it was to recycle. So it was actually partially a regulation and partially an industry solution to reclaim all those raw materials. This also coincided with the materials starting to get to be more expensive. So they were already starting to eye those junkyards as valuable rather than just a dump. And then so that resulted in this highly closed loop system that current vehicles enjoy. And I noted already that the plastics are the one thing that are not fully recycled. In terms of we're jumping into the electric vehicle section here. The electric vehicles that we've already mentioned a couple times. Do we have any questions, David?
No questions at the moment.
Oh, all right.
Okay,
I'm trying to watch for hands.
right.
I've mentioned a few times already that electric vehicles don't have that closed loop cycle with these components that are not common to your gas vehicle. So the battery is the major component there. It's almost the only component of an electric vehicle that's not common to a gas vehicle, because while it has a lot more copper, for example, electric motors are not a new recycling problem, and they're pretty easy to recycle. They do have some plastics in them that can't be recovered, so those are burned off or melted off, but the copper is recovered, the metal is recovered. The permanent magnets that get used in most electric vehicle motors now, they are not easy to recycle, but they can be recycled, and companies stockpile them because they know that they'll have a value in recycling later, and there's such a small volume of them that they can be physically stored. They're actually difficult because of regulations to just chuck, because they're really powerful magnets, and you don't want those just chucked into a bin and a dumpster somewhere, and they'll stick to the sides. You can break fingers. I mean, it's permanent magnets are no joke, and I've seen them jump like a couple of feet across a table and then have two magnets jump to each other and slam and then fracture into like a whole bunch of pieces that just stick together. There's a big clump of magnet material. So it's very, very strong stuff. So they stick them in crates that have metal lining on them so that things can't get attracted by the magnets, and those get stored. And there's companies now that are, including like Honda, General Motors, and other smaller private companies that are starting to seriously recycle them because it's starting to be cost effective. So so you got everything except the batteries can be pretty effectively recycled already with existing infrastructure, and there's an incentive to do so. But in terms of the batteries right now, the only company that seems to be making a serious effort, that's a manufacturer of batteries, is Tesla. They claim that they recycle up to 60% of the battery. I don't know exactly which components in the battery are recycled. They definitely don't recycle the plastics. They include things like the coolant liquids in that number, but they don't dump what they can't recycle in terms of the lithium and cobalt and manganese and other materials. Those get stored until they can figure out a way to recycle them. And the real reason for that, the real incentive for all these companies to not dump any of these, is if they were to give everybody an electric vehicle to trade for the gas vehicle they already had, we'd use up almost the entire known amount of lithium that we could mine in the world, and using current battery technology with lithium and stuff like that. So you wouldn't be able to make a new vehicle after that point if you were just throwing the old vehicle batteries in the garbage. They have to be recycled just so you could sell somebody else another car. So to kind of conclude here in terms of the batteries, and do stop me if we have a question.
I will, yeah.
The batteries are not at the end of life yet. There's the first vehicle that was really sort of commercial that went on the road with lithium-ion batteries in any significant way was the Tesla Roadster. You also have the Nissan Leafs. There were some hybrids like the that had very small lithium batteries, but a lot of the ones people think of, like the Prius and stuff like that, had batteries that didn't use lithium, nickel metal hydride, which have to be much bigger for the same amount of range. And so that's the reason they don't use those commonly. Those batteries are still operational for the most part, unless they were damaged by an accident or a manufacturing error. So the Roadster batteries are still good. Even when they have a problem, they can sort of just swap out a couple bad pieces and put that battery right back on the road with 90% or more of the pieces still in there. So we're not kind of at that point yet where industry has to face the challenge of batteries stacking up in warehouses waiting to be recycled. We're hitting the cusp of that, mostly due to accidents and stuff like that. But compared to the overall vehicle scale, it's a small problem right now. So there are a lot of small companies and university research programs looking at recycling batteries. And one group will claim they have a solution, but then it doesn't really turn out to be a commercially viable solution. That's pretty common in any new technology area. One of them will eventually be, or one that we haven't yet discovered will be. But out of all the companies, if you look at General Motors and Nissan, stuff like that, the only one who seems to be making any publicly documented effort to actually recycle batteries right now is Tesla. I'm not trying to steer you to buy Tesla, but that's just how it is. So what BMW and Nissan and other companies do right now is they do take the batteries back if they're damaged beyond repair, and they just get stored. They get safely stored. So you're not gonna, hopefully not gonna see on the news about gargantuan lithium storage fires. And if the battery has usable pieces in it, so the battery needs to get replaced because it has one bad cell out of like 1,000, if they can't fix that battery to go right back in a vehicle, either because it's too old or too expensive, that battery still goes on to a second life that it might be at for 15 to 30 more years, managing electricity for the electrical grid. So they don't have to be as small and high performance when they're just sitting there on the ground and not being driven around. So when they say a battery is worn out in an electric vehicle, that's when it has 80% of its original capacity when they gave you the car. So if you had a 200-mile range car, that means that it can still drive 160 miles. And then they would say your battery is worn out. You could keep driving it too. But at that point, like if it was under warranty, they would replace it, and that battery is totally fine. It's going to go to a second life application like grid storage. And that's a big thing that Tesla does. So a lot of those, you may have heard in the news like a few years back, they set up big grid storage in Australia. They recently set up a whole bunch more. And they're targeting the US market, Puerto Rico, and everything like that too. And a lot of the batteries that are going into those big, giant, multi-megawatt storage situations are batteries that couldn't get put into a vehicle or put back into a vehicle.
Sean, quick question for you.
Yeah.
So I think in California, they allow, or batteries are required to have a life of 10 years or 100,000 miles on cars, right? But it sounds like you're talking about a couple of different types of batteries now. So like the Prius has a different type of battery versus the Teslas and so forth. So could you explain what, at least, is there a 10-year lifespan more or less guaranteed? And then it's, a little more about that if you could.
Yeah, so there's two major, well, there's multiple major types. So you have nickel metal hydride, which is an older style battery. It's like an industrial battery. It's very stable and safe. It's been around longer than lithium batteries in commercial use, but it's much bigger for the same amount of capacity. So it got used and it's still used in hybrids. Not all hybrids use nickel metal hydride, but the Prius was one of the biggest users of nickel metal hydride. And that's a pretty recyclable battery. And then and there's new research in that and making them better too. So those may come back. And then there's lithium batteries. when you talk about lithium batteries, there's actually some critically different kinds of lithium batteries. So one that's used very commonly in lower cost stuff, mostly grid storage, is called lithium iron phosphate. The important thing to know about lithium iron phosphate is it doesn't like do the whole fire issue. So it doesn't burn in the same way. It doesn't heat up in the same way. They like to call it inherently safe battery. There is really no such thing as any type of, I mean, you think of lead acids, they also call it inherently safe, but you can still cause it to explode and get acid burns, right? So it's only so safe, right? But it's still like a regular person can handle lithium iron phosphate and abuse it and use it and not cause like big issues. And then there's lithium polymer batteries, which heat up when being used a lot more. They're more prone to fires, but they can store a lot more energy and discharge a lot more energy in the same size. And they're more fine tunable from like the chemist's perspective as well. And then those have like 100 different flavors as well within them. But even an engineer like myself doesn't really care about those flavors. We just care about the numbers on that we're told. But that's the most common kind of electric vehicles. Tesla recently announced that they're moving to lithium iron phosphate as the battery of choice. I think that's a combination of a supply chain issue because they're safer and they can be shipped without special considerations. They're easier to move around and build. And that also like a PR issue because you won't keep having like Tesla fires coming up in the news if they're lithium iron phosphate. But in terms of performance, most cars are using lithium polymer batteries, which is the same thing you'd find in like an RC car or, and there's one of the flavors of them is like what you find in your phone. That's not the exact flavor that you find in the car, but it's a similar thing.
Oh, Sean, I had a question. You said that the Tesla Model X has exceeded 327,000 miles.
Yeah, that was a particular example. I think that's the known highest mile one at the time I did the research.
Okay. Do you expect, and maybe you can or can't answer this, but do you expect that number of miles to increase, or do you think at some point there's going to be like planned obsolescence where they don't want the batteries to continue forever? 327,000 is a lot.
Well, and this kind of goes back to Ray's question. I realized I didn't fully answer. So we engineers play games with numbers. And if I have a battery that will deplete to 80% of its capacity after you use it most of the way and recharge it, say 3,000 times, which sounds like a lot, but people can do that. Like if you're doing a daily commute, you might do that every single day, that you're commuting, deplete it and recharge it. And so if you want to last 10 years, like you're already there, right? And then some people who are driving like a taxi or doing courier work or stuff like that, they might do much worse than that. But what if I have one that only goes 1,000 times and then it's down to 80%? But if I know that it will go down to say 60% in 3,000 times of use, then what I'll do is I'll tell you that the battery only has the capacity as if that 60% was 80%. So I'll basically lie to you about how much, I'll put a bigger battery in than I tell you I put in, maybe because it's a cheaper type of battery and I have the space to put it. And then I'll just use the computer to not let you use that battery all the way so that it will still last for that warranty period. So that's what, when you have different kinds of batteries that have different levels of endurance, so to speak, like that's what engineers and car companies will do. And it's not a planned obsolescence. It's a making sure that we hit that sort of customer and regulatory requirement. So that kind of, though that in any other product does kind of result in that sort of planned obsolescence, bad word. What I've learned after being an engineer now for almost 10 years is that there's almost never an engineer out there who's planning for your product to actually fail at any point, unless it's because it's going to save your life or something, like they want it to break in a certain spot or not, but like not just because of using it normally. We don't ever plan to make that product fail so you have to replace it. The sales team may go, well, we really would like this product to not last as long, but the engineer is not going, I'm designing it to not last as long. But what they're doing, they're told is how long it has to last and under what kind of conditions. So the engineer only designs it to be as good as is required, usually for some number that sales comes up with. It's often like 95% or more of all the customers who use it to be happy within the warranty period. You know, of course, that 5% complains a lot, right? Oh, it broke on me, you know, halfway through the warranty period, or it broke on me like 2 days after the warranty period. If it's when you hear a lot of those complaints, like it broke 2 days after the warranty period, that means the engineer did a really good job of keeping you happy during the warranty period, not that they planned for it to fail right after, right? So from the engineer's perspective, they're not going planned obsolescence. I basically never seen that. And it's a hard thing for me because I was very much in that, you know, planned obsolescence like is a thing, and evil corporate structures are a thing, and you certainly get people who hide behind the separation of layers of management and numbers and do sort of what you might label as evil things because they've distanced themselves. If you were to think about that zone concept, they put that the consequences of their decision way out there in zone 8. Even though it's actually really close and dear to them, they can think about that in their mind as really far off because there's like 5 people between them and that consequence. And so, you know, maybe big corporate structures create the you know, system that causes incidental evil, but I have yet to see like intention. You know, like I have yet to see the intent to cause something to fail 2 days after your warranty ended. But I have seen the intent to make sure it lasts until the warranty is ended, right? Which kind of results in the same kind of thing, you know.
Sean, do you have more slides, or maybe we can, if not, we can maybe stop
Yeah,
share,
that's what I had for tonight's class.
Okay, great.
Let me see if I can.
If we can get everybody back together there. Okay. Great. Okay, well, does anybody have any other questions they'd like to share with Sean? Now, next week, you might want to go over a little bit of what you'll be talking about next week, and probably going to do that.
Yeah, I'll talk about next week about how green is it while you're driving it. You know, where's the electricity coming from? Is that a lower pollutant than burning gasoline in your gas car? And also a little bit, you know, there's the question of where does the gas come from, right? And then what's different in terms of other things that get disposed of, tires, brakes. Those are things that get used up and are not, tires can be partially recycled, but are not generally largely recycled. Oil in your vehicle. So a gas vehicle has a lot more oil in it because there's a lot more moving parts, and you need oil whenever you have a moving part. So that's a good thing to think about. That's just part of that total equation for you answering in your head. Am I actually making a decision that's ecologically or ethically better in my measurement if I get an electric vehicle? So, but if you want to ask questions about owning or using an electric vehicle, I'm happy to answer them now since we've got a little time.
Well, let's see, I had a couple of questions. Why, since you mentioned that, why are electric vehicles so much more expensive than a traditional car?
Well, a really big part about it is the battery. It's finding the materials and getting the materials in a cost-effective manner for the battery. Another really big part about it is you're not buying a car that's had very small improvements every 2 or 3 years for 100 years. You're buying a car that's had huge improvements every 2 or 3 years for like 15 years. So there's, you know, hundreds of times the engineering cost, plus they're making far, far fewer of them because there's fewer people buying them. And this is really hard for the big automotive manufacturers, because getting a car built up on a production line in volume is a multi-year endeavor. And so that's years that they've got hundreds or even thousands of people working on getting that car to just deliver the first one. And then if they only make 1,000 of them or 1,500 of them before they then make a major change, you know, that's a lot of money that they're really not making money on electric vehicles right now. Tesla's probably just at that point, or maybe is at that point of making money on it.
I have a question here from Byron. He
Right.
says, did you see that? Have you seen his question?
Yep.
Uh,
Regarding the 2010 Ford Fusion, and how do you know if the battery was placed before you got it? I would just ask the dealer. They'll have to keep track of the information, because unless it was done aftermarket, which if it was a Ford Fusion hybrid and not an pure electric, it's possible. People do make aftermarket batteries for the hybrids like Priuses and stuff. And for some of the older Leaf that had smaller batteries, but then someone can look at it, you know, and see right away it's an aftermarket, or there'll be a record if it was done with the original equipment manufacturer OEM battery. That'll be on record. So you could just ask your dealer and have the mechanic check under the car. Yeah, if it's owned by the state, then you'd have to go through your fleet manager probably. Jim, were you trying to ask something?
Yeah, actually, I did have a question. Maybe I should wait till next time you tell me. It was about plugs going to
Right.
public charging stations. And I'm finding that not all charging stations have the correct kind of plug for our Chevy Volt, which is, I think, called a J1772 plug.
Yes.
5-pin. And I see somewhere part of the plug looks like it's match ours, but then it has this extra thing, which I think is called the CSS combo, and that won't fit in our
Yes.
car. So is there like an adapter?
So the ones that have the combo are fast chargers. So if your car is not equipped with a fast charging connection, then you can't use those. So the J1772 standard is a universal standard for connecting AC power, like just connecting the grid to your car. So the actual charger in that scenario is inside your vehicle. So the charger from an engineer's perspective is what takes the regular wall grid power basically, and then converts it for charging the battery, actually manages that. So the J1772 without the CCS combo, all it is that box that you're connecting to is for safety reasons. So it's there so nobody can get electrocuted. And it's also there, it talks to the car, and it only turns the electrical connection on, like plugging it in or flipping the switch, when the car says, hey, I'm ready for it. And then the car has the charger on board. When it has the combo plug or other fast charging, so like Tesla has their own proprietary fast charging. And then there's one called Chademo, which was like what the Leaf and a lot of cars used until recently. That's like a big circular one. That's another fast charging thing. That one, the charger is actually in the box that you're plugging into, and it's charging your battery directly. So your car has to be set up for that. So it's a different connection, and some cars have both. And that's that CCS combo plug. It uses the same port, but it puts that fast charger in like two big plugs underneath the round port.
Yeah.
And then what it does is it only uses the communication, the talking part of the 70 and 72 plug. and then it uses the two big prongs to use the external charger, and it can charge much faster because it's a giant charger in a box versus the little one on your car.
Thank you.
No problem. And then there's a question from Steve about Hoverman, about using your vehicle battery to supply electricity to home at night. That's a great question. We call that vehicle to grid, or V2G. You'll see all the time get tossed around. That is something that people have been, engineers and scientists have been arguing about and still do, because it's still not really known if that's going to be beating your batteries up and then, essentially wasting the money you've invested in that car for you as the owner. How do you compensate the owner for that? And really, how useful is it? And then is the equipment. So again, that charger that's on board that talks between the direct current side on the battery and the alternating current side in the wall, it would have to be able to go both ways, which would make it a little bit bigger and more expensive. And then it has to know how much to send to the grid. Or in some case, the grid wants you to actually suck electricity down, because they can't change how much electricity they're producing at a power plant very quickly. So if they ramp up the power plant because they're expecting people on a hot night to use electricity, and then people aren't for whatever reason, then they're making too much, and they really need people to start charging their electric vehicles. They want to be able to tell it how, and nobody's come to agreement. Like all the regulatory agencies and power companies, they're still fighting over how are they going to tell the car. So a lot of the manufacturers have made cars, or started to make cars ready for it, but they'll have to update the software, and you'll have to have a particular, they call it the electric vehicle service equipment. That's the plug on your wall with the J1772 plug that Jim mentioned, that will have to have an update or be a different set of equipment so that it can talk to SMUD or PG&E, and then they will tell your car how much power to give or take in order to make the grid run more efficiently. So is it possible? Some cars have that as hardware on them, but it won't do it right now.
So it's possible someday that your car might serve as a solar panel, perhaps, or kind of.
Well, as a battery storage.
As a battery.
Yeah. Another way to think about this, and why it may not happen or be worth happening, though, is that batteries are getting cheaper and cheaper and cheaper, because they're using less cobalt, less lithium, and they're just getting better at it, and they're making them in bigger volumes. So as they get cheaper, the reason people wanted to use the battery in your car for this extra purpose is because it's so expensive. If it's not expensive anymore, it will be even better to just put a battery that's always on the side of your house, right? It does the exact same job, but it's always there, and that's its only job. So that's things like your Tesla Powerwalls and competitors. Their batteries there. And then again, though, those don't have to be super high performance batteries, right? So they can be a different kind of battery that's safer. You don't have to worry about PG&E setting your car on fire because it asked it to do something ridiculous in the middle of the night, right? So, I mean, the car should stop itself from doing that, right? But that's always a concern you're always going to have, is that they're going to really beat up your car battery, and they don't care. It's not their money. You're saving them money, and they may or may not be compensating you for that. And we don't really know how much damage they're doing or not doing yet. Lots of testing been done on it, but when technology is changing constantly, that testing is kind of like old and not useful anymore. So it's a great question. It's a complex argument, you know, and people are been fighting about that for more than a decade, and probably will be for more than another decade.
Thank you, Sean. I'll jump in. I have solar panels and have had them on my roof for 15 years, but that's the route I was going to go, you know, thinking I could get off the grid, power the car with the solar panels, but similar to a battery. What are your
Yeah.
thoughts about using that combination?
So yeah, so you can totally charge your car. And it just, unfortunately right now, there isn't any car you could buy that is
Yeah.
going to let you run your house off of it without, cutting into it and making a lot of changes. Except for, people are taking like some of the Ford trucks have
Mhm.
generators on them. They're starting to use those, but it's not exactly the same thing as using your electric vehicle battery. But so yeah, in terms of that, but you can have a wall storage or just batteries that sit stationary on a wall or on the floor somewhere. And people have been going off grid using just lead acid batteries for a long time doing that. The one thing you have to be careful is if most people choose to stay connected to the grid, but have the ability to disconnect like in a power outage. So your power supplier will charge you for having a generator, because from their perspective, electrically, it's the exact same amount of headache. Because when the power comes back on, if your generator doesn't reconnect back to the grid properly, has a switch that does it automatically, then it can cause them all kinds of problems. And so they have to regulate that. And there's also local and state and federal regulations regarding generators. So they charge you extra every month just because you have it. If you don't have the ability to run your power with the electricity, the grid off, so this is just assuming you're still connected to PG&E or SMUD, but when they go down, you want your lights to stay on. If you don't have that ability, you won't be charged. You could have the batteries. The batteries will only work while the main power is connected. And what they really do for you then is possibly save you money. Certainly allow you to keep your solar electricity local at your house, which possibly makes the grid a little bit more efficient. But mostly what it would let you do is sell the most electricity back to your provider when it's the most expensive. And so they have to pay you the most for it as a credit on your statement, just like you do with your solar. If you have net metering,
Yep.
So you could say, sell them the most during peak because you store it in the battery when it's cheap. If you're still producing more than you're using when it's cheap. Now it is technically illegal to take electricity from PG&E or SMUD just to charge your battery so you can sell it back to them when it's expensive, even though it actually saves and makes them money. So they should want it, but they currently don't, because they also, a big part of their thing is, again, scheduling those power plants that take hours to warm up and cool down. And so they want to know pretty well how much they got to spool up that power plant. And so that's they're mostly afraid that if lots of people like you, Steve, have batteries and then charge when the electricity is really cheap and then sell electricity, say, to your neighbors through them, saving them money, and they don't need as big a wires going to your neighborhood, right? There's lots of benefits to them. Transformers aren't exploding, like it's good for everybody, but they don't want that to happen and suddenly to be like, to have spooled up a power plant to provide that electricity to all your neighbors, but then you're doing it and they can't easily see that you're going to do it. And so then they might have a power plant that they're spending money to run that they didn't need to. That's what they're afraid of. It hasn't actually happened.
But a good idea. Thank you. You're as knowledgeable about SMUD and solar panels as vehicles.
They're interrelated to electric vehicles. Yeah. So I also have solar, but I don't have batteries, because with SMUD, it's like really hard for the batteries to actually save you money. But yeah, when the transformer blows at the substation near my house on a hot summer night, I really wish I had the backup generator set up with the batteries. I do. But that's like once a year, so.
Yeah. And so this last Sunday on TV, I saw that was a Ford F-150 that was powering a house at night, but I missed the comment that it was through a generator.
So the engine runs, and even if they have a hybrid version or something like that, it can only do it for like a short period of time before the engine would have to run. to charge to provide electricity. So it's not like it's kind of similar to what you were saying, using your electric vehicle. The other difference is it's not set up for your grid as a generator. So you'd have to go and disconnect. You'd have to have one of those big pole disconnects,
Yep.
kind of like what you see with the mad scientists do, except it's in a box so you can't electrocute yourself.
You've got solar panels, so you have one on your house too.
I do,
Yes,
right.
yeah.
So you'd have to have one of those that would disconnect your house from the grid. And they will not actually let you do that legally. So, so those people who are powering their house with their Ford F-150s are either somewhere where they're not as tightly regulated, or they're not technically doing it in a legal manner.
Thank you. That's off the subject from tonight, but
Oh
I
yeah,
appreciate it.
it's all related.
Yeah. Okay, Sean, did you discuss a little bit about what you were going to talk about next time? I think you kind of started going there, and then there were some more questions. And
yeah, so
if there are more questions, I think we still have some time.
Yeah, but we'll talk next. I'll talk next time about, and I hope you guys have lots of questions about how green your car is while you're driving it and owning it versus a gas vehicle. That's what most people think about. So that's like, I think most people go, oh, well, it doesn't use gas, so it's obviously more green, right? So I really wanted people to think about the end of life and the start of life of your vehicle, because those are actually, that's the main thing that people who are against electric vehicles argue that makes them dirty and not green, is that they're dirty in manufacture and end of life. I hope I've helped you understand that that's not really the case. It's sort of an unanswered question, but it's a question that has to be answered in a way that is as green or greener than gas vehicles. So it will be. It's just currently in a question mark right now because nobody's doing it yet. It's too young. But in next week, we'll talk about, while I'm driving it, is the electricity I'm using green. Steve's is, right? He's using solar, right? So unless you're going to make the argument that the solar is not green, maybe because the solar panels came from a war-torn country and they used small children to do it, I don't know. But like, so like you could argue that the solar panels itself might not be green, but in terms of like, there's no more pollutants once those are built. Those are going 15 plus years without polluting in order to generate electricity. And so that's a lot of potential driving in your car that has green electricity there. Same with a wind turbine. Hydropower, we could talk about that kind of like off the slides next time. That's I think if you asked engineers and regulators, every one of them is going to have a different opinion on whether that's dirtier than petroleum or cleaner than petroleum.
Ah.
But yeah, so it's I think that'll be the subject where people have most questions, I imagine, is the ownership part. And then we do have a few more minutes if there's anyone who hasn't owned an electric vehicle, wants to know what it's like to own. And so it is.
What do you drive?
Is it like?
I had a Chevy Spark electric. So for all of us who live here in Central Valley, you can turn the air conditioner on with your remote control, right? That's a reason to buy it right there. The heater too. So if you're cold in the winter and you get in, but it's like, just frankly, as they're the nicest cars to drive. They're so smooth. They generally, almost universally, even the Leaf, which is often criticized as being kind of a sluggish low performer, is really smooth, and gives you like really what you expect to happen when you press the pedal. So it's really just a pleasure to drive. It's like as close to turning your car into the ideal theoretical car you think about in your mind as possible. It doesn't shift gears. And because the battery and everything is so expensive, they kind of, for perception reasons, have to make the interior generally really nice. So it does kind of put it in a luxury car category for the most part. So like my Chevy Spark had really nice leather seats. The ergonomics were great. It was just, everything felt really good. It felt really solid in turns. And again, the air conditioning was just like fantastic. Like you could be wearing a coat in the summer inside the car. It was great. So yeah, it was like a luxurious experience. Except for when you're worried about running out of electricity because you overestimated how far the battery could take you that day. Or even if you didn't and it's got plenty of range, you may still worry about it. So they call that range anxiety is what's commonly called. So even if it's not a legitimate concern, it doesn't mean you don't worry about it, right? So because you can't just go and fill up in anywhere. And then you do worry about people vandalizing your car when you're out because people get really mad about electric vehicles.
What was the listed range for your Spark?
80 miles. So most vehicles now that are all electric, most of them well exceed that range. But I drove it 34 miles each way to work, right? So that was really close to its range. Now, when I was driving to work in Dixon, we were building electric and plug-in hybrid trucks for PG&E mostly, and for some Chinese customers. And we had chargers, or we had the electric vehicle service equipment, the plugs with the J1772. So I could charge at work. So that kind of eliminated some of the anxiety. And then every electric vehicle comes with a charger with one of these service equipment things that can plug into a regular 110 volt. That will charge it very slowly, but it does charge it. So if you're parked, if you have like a 30 mile or less commute, and for whatever reason, there's a 110 volt outlet right where you park your car, maybe you went to visit a friend, then it's totally possible if you're going to be there all day to charge on the 110 volts. But if you're going like a couple hundred miles on a trip, you're going to want that fast charging capacity. And then you're really going to want the car with the longer range. So Byron just asked that question. If you were going to go from Sacramento to LA. So if you didn't have a fast charger and you didn't have, a couple hundred miles of range, it would be a multi-day trip. Because so my Spark, for example, it didn't have the fast charger. And so if I were to drive 75 miles and stop before it died, because I didn't want it to die on the side of the road and call AAA for a tow, which happened to me more than once. Not going to LA, but just driving around. I'd stop somewhere that I would have a charger. I hope that somebody didn't block it with their electric or gas vehicle, which people totally do. And that it wasn't cut or vandalized. So this is an issue that's becoming less and less of an issue with more government investment and these, but you might find you get there and you're unable to use that charging station. But even if you get there, it would have taken six or 7 hours to recharge that much range. So you drive for like an hour and then you'd stop for like 6 hours if you didn't have the fast charger. If you have a fast charger, if you took a 200-mile range Tesla or something, for example, you could drive your 150 in a couple hours, 2.5 hours. You want to stop and take a break anyways, you plug it in for 30 minutes in the fast charger and you're going to have recovered most of that, 80% or more of that. That does, if you were to do that every day, day in and out, that would totally wear your batteries out. And they will actually stop allowing your vehicle to fast charge. Is something that Tesla does that bothers some people, but in order to maintain the warranty. And that's part of the giant paperwork you would sign with them. But very few people are driving, hundreds of miles and fast charging multiple times a day, every single day, right? That's an edge case. Maybe Jim and Fred are planning to do it, but but yeah. But people do it. People drive. There's a charging network along the north, central and southern United States now. It's not super awesome through the South and Midwest, but along the North, it's pretty solid along major freeways for not just Teslas, but regular cars. And they're increasingly adding more and more stations, more spots to charge at each stop, and then more stops so that there's more frequent stops possible. And then there's a really good one between Sacramento and LA. So there's lots of places to stop for fast chargers between Sacramento and LA, but they're really built around the idea that your car can go at least like 100 miles between stops. So that if you couldn't charge at one place because people had just parked and they're going to be there for 40 minutes, you could go to the next one still, right? But you couldn't maybe go another one and another one like you might be able to do with a gas station. If you were like, I'm going to fill up when I'm at half a tank. Oh, well, I'll just go to a quarter of a tank. You know, it's a totally different thing because the gas vehicle might go between 300 and 600 miles, depending on the size of the tank on your particular vehicle. So it's definitely something that's slowly developing.
And then you get into that whole thing with the, the hybrids and
right,
which can also be charged. I know most people I know that drive hybrids, they don't charge it. Like if they have a Prius or somebody,
right.
they don't have a charging station. I think I only know or a charger, but you can, there are cars out right now that you can charge and you still have gas. I mean, it's
right.
considered a hybrid. Yeah.
Yeah. So a hybrid would have no charging capabilities, but it uses, when you slow the vehicle down, if the battery is empty or isn't full, I should say, it will use the electric motor to slow you down instead of rubbing and wearing down your brakes. So it saves, it recuperates or regenerates, they call it regenerative braking, some of the energy you use to get going. And then in that, it saves you gas, right? So your basic hybrid Prius or Fusion hybrid, those kinds of things will do that. They'll save you money by making it a more efficient gas car overall. Excuse me. A plug-in hybrid is like a really small range electric car with a gas engine as well. So it can operate without ever plugging in, and it does that thing where it will make it a really efficient gas car. But you can also plug it in, and typically it's like 10 or 15 miles. I don't know which version of the Volt you guys have, Jim and Fred, but I think they had up to 32 miles in the last version.
Ours actually is a 2017. It was listed as a 60-mile range. So most days, I mean, we can go for a couple weeks or more without using the gas engine. We charge at home.
Looks like Byron had another.
He had a comment that the Fusion, he
Freeway.
sometimes gets about 38 miles to the gallon.
Oh, on the free, just getting off the freeway, it charges like, typically 38 miles. Yeah.
Yeah, I mean, and in contrast, you can get about that with like a Honda Fit. That's not a hybrid. So, but it's a smaller car, right? So hybrid is very popular. Was very popular early on, and may still prove to be popular in things like trucks and stuff, where electric vehicle is sort of a bad word, but they're trying to chase a higher fuel efficiency, right? Because even though you might drive a truck because you feel like little efficient cars are somehow bad for America or whatever your reason is, and electric vehicles are somehow bad, you still don't want to go and pay all the money at the pump, right? And the EPA still doesn't want you polluting as much. And so people are generally quite happy to get more fuel economy, and a hybrid is a way to do that and kind of like hide the electric vehicle under the hood. It's also cheaper because it just has little batteries and often doesn't have as big a motor and stuff. And a plug-in hybrid, though, it's a really tough thing from a market perspective, because it's like a full electric car that can't go very far as an electric car. And that means you have to have the full size motors and full size equipment, and that battery has to be able to provide as much performance or nearly as much performance as the vehicle would have if it was like just gas or all electric. And that's really hard when you take a tiny battery and it's doing the horsepower work of a big battery just for a short period. That's really hard for the battery. So plug-in hybrids are really tough design case. They're actually more expensive to design. So you don't see very many of them for that reason. So it's usually a hybrid or all electric, and all electric starts to be a much simpler, other than the battery, the vehicle overall starts to be much simpler to do. So if you can figure out the battery solution, which is starting to be the case, then the vehicle's just really easy at that point. It's just that darn battery box is like a lot of work.
Do you find that when people say, especially if they haven't had a hybrid or they go from a gas car to electric car, that I guess it depends on the comfort level of the person. Like if I was always kind of afraid that if I get an electric car, I have to know so much. I have to be an engineer practically. Do you find that that's a problem? I mean, is there like a training for your for electric cars? I mean, maybe that was not necessary, but
yeah, I think the only real thing when it comes to the electric car is the charging your car. That's the big challenge. Unfortunately, even still to this day, dealers rarely have somebody who really knows anything about an electric car, and a lot of the time, because of the price, the salespeople don't make enough money to own one.
Mhm.
So there's a deficit there of understanding.
Mhm.
But in terms of actually owning and using an electric car, you're going to get in, turn it on, you're going to drive. If you're driving with an automatic, which is transmission, which is so common now, it's just going to feel like the most smooth automatic you've ever owned.
Really?
Because there's no shifting, or there's almost no shifting.
Mhm.
And so for all those perspectives, everything's going to be exactly like, it's just going to be like the smoothest, nicest car you've ever driven. The
Yeah.
one caveat is if you're charging, and really that's only an issue if you're not charging at home. So in the case, Jim and Fred's case, they're probably charging at home because they're not driving really far. But if you're commuting a lot, like to work or to family, or even doing trips that are further, like Byron just made the point, if your trips are very few and far between that are far, then it can make a lot more sense to rent a car on those rare occasions, or to have a gas vehicle that you're willing to own and not use very much, that you use for longer trips.
Because of the charging stations or lack of.
Yeah, lack of, or the time it takes to charge. Because even if they call it a destination charger when it's like somewhere you're going, like at the grocery store or the casino or wherever, if you're not going and staying for a long time, you're not getting any really meaningful amount of charging out of that connection. And then they're rarely free, unless it's a government sponsored thing like a city hall or a school or Air Resources Board always has them. Usually there's an Air Resources Board employee plugged into it though, so it's not usually available. But yeah, you can go like to Arden Fair Mall, and the charging I believe is free, or it used to be free there. It was free at or low cost at the mall in Roseville. But if you go to IKEA, it's actually quite expensive. And they have the charging plugs at every IKEA, but they're like one of the most expensive places. It costs you almost as much as if you were refilling your car with gasoline, like mile for mile.
Yeah, I wouldn't have thought that.
Yeah, so it's like, they make a big deal about having the charging plugs, but then like it's really expensive at IKEA compared to other places. Rayleigh's often has chargers, at least in this region, but you know, again, like if you're parked at the Rayleighs for 40 minutes, you're only getting like 8 miles of range out of that charger. So it's not, if you had to drive, you know, 20 miles for whatever reason to get to the Rayleighs, it might be a noticeable amount, but it starts to be insignificant, you know. But if you're going to work and you're parked at work for 6 hours or 8 hours, you can completely recharge, even if you showed up at work with a dead battery, or just about dead, because otherwise you wouldn't show up. But but yeah, so, you know, like I used to go take the Spark to my parents in Elk Grove, and it's close to 40 miles from where I live. So we'd go there before we had Edra, before we had the third kid, and we could just, if we took surface streets and not the freeway, which was a shorter distance, we could make the trip back and forth. But if we took the freeway, we would possibly run out of juice on the way home, which happened to us once.
Oh, really?
And so we would plug in just to the 110 volts with the charger that came with the car, and we'd stay there for like 4 hours, and we'd get, you know, 16 miles or something back, which was enough, more than enough to confidently make it home with what we had left when we arrived. So, but that's a concern.
So what do you do when you run out? Like, what happened at the time that you didn't make it? You call AAA, or I mean, did they have a charging station?
Yeah. So the first time it happened, we got the car when we were about to have Fletcher, our first child. We had a Smart for 2, which was a 2-seater. And so obviously couldn't have the kid in the Smart for 2. So I got the Spark Electric. I really wanted it. It was maybe not the right choice at the time, but I really wanted it, working in the EV industry. And yeah, so Crystal was like 9 months pregnant, and we came back from shopping, and it was raining and it was dark, and it died a mile from home. And so she walked home in the rain with the groceries, and I pushed the car.
Oh, no. Oh,
and then was able to get to push and roll it far enough up the driveway that I could plug it in with the charger. So we got a lot more cautious after that.
yeah.
We had it die once, like 3 miles from home, and well, it was about to die, and I was starting to be pretty sure we weren't going to make it. So we pulled into a well-lit elementary school parking lot and called AAA, and then had a neighbor come and get Crystal and the 2 boys. At the time, we didn't have Edra. And then shortly thereafter, we did have Edra, and so we stopped. It basically just became my commuter vehicle. Or if I took just the boys somewhere or something like that, because with the only 4 seats, we couldn't fit all 5 of us in the car. So then we have a station wagon. That's a gas vehicle. That's what we started using and use primarily now. And I do hope to switch back to an electric in the future. But yeah, it's an investment. And I'm kind of personally, I'm at this point where I'm kind of waiting to see how the market pans out, who's gonna stick around, you know. And so, you know, yeah, a Tesla might sound great, like a used Tesla. That's expensive still, and then there's question marks there. And then, you know, Chevy Bolt, I totally have a Chevy Bolt, even with the fires today. Like, it's very, very few vehicles have had a problem. They're addressing it. Whether or not they've absolutely 100% addressed it, maybe I wouldn't park it in my garage, but the actual risk to you is really, really small, and they're pretty cheaply available right now because people are in a panic to get rid of them because of the press. But, you know, that's fully under warranty, right? Like, so that I can guarantee you as an engineer, there is no way that they will not either buy the car back at a value that is worth having the car to sell back to them, or fix it. There's no way that won't happen. They will be forced by the National Highway Transportation Safety Administration, who does the forced recalls, which hasn't happened yet. They would be forced to do that. So that's another thing to keep in mind. Those recalls almost always are voluntary. So those are the companies going, for PR and liability reasons, we are trying to fix this before it actually becomes a huge problem. It's very rare that the government actually forces a recall on any vehicle.
Yeah.
We have run quite long, so at this point.
Okay, all right. Well, thank you so much. And
Thank you.
as I said, this, we said earlier, this has been recorded, and which would be good because I know we have people that couldn't make both sessions. We'll be back next week at 7 o'clock next Thursday. So we'll be recording. It'll be on the UUSS website. We'll arrange it for that. And I wanted to thank Sean, and we'll thank everybody for coming. And on behalf of the Adult Enrichment Committee, I wanted to thank Sean for doing this for this week and next. It's been quite informative. I've learned a lot, and we'll continue to learn more next week. We'll look forward to that.
I look forward to it too.
Okay, anybody have any other last comments or? Okay.
Thank you.
All right, thank you. Thank you everybody for coming. I know a few of you have left, but thanks for being here tonight.
Next week.
Thursday. All right, bye.
And next week.
Okay, bye.
Bye.